Hello, everyone. My name is Ankit, your host for today's session. If you can hear me loud and clear, please do respond as yes on the chat window. Can you hear me? Great. Thank you for information, guys. So I'll be quickly transferring the presenter access to the trainer in this session. You can wait for 4 minutes and you can start off with the session.
Buddy, for 3 more minutes, and then we'll start at sharp 7:30. Good evening to everybody. Let's start today's session. So before we go ahead with the audible. Okay, recap what we did the other day, yesterday. Yeah, uh, anything so far, so you are not able to see anything. Don't worry. Yeah, we went on to consolidate our concepts of statistics. We showed the different types of variables, and we learned distribution. We go for T statistic when we should go for a Z statistic. And did our discussion on hypothesis testing. Several examples of hypothesis testing. We understood how we can go about finding out the evidence so that we can reject or accept the null hypothesis. Uh, Quest to evidence, we learned of error we may uh, while rejecting or accepting the null hypothesis. So type 1 error we discussed, and we discussed our type 2 as well. We saw that type 1 error is a kind of risk threshold. Type 1 error basically tells you risk which you are taking along you are rejecting the null hypothesis, and that is also called as p-value. I say that this p-value is compared with that of significance level, and we make the decision to either reject or accept the null hypothesis. If value is less than significance level, we reject the null hypothesis, and if value is more than significance level, we don't reject the null hypothesis. This is what we discussed. But we also imported one data set HYP, and data set we completed with the discussion of one-tail and two-tail hypothesis testing. Also had a discussion about paired sample t-test and independent sample t-test. We have yet to do it on SAS. Okay, so let's begin our discussion from where we left yesterday. Anybody, any question? If you have, you can please ask me. Yeah, no problem. I'll share all the codes. I promised you that I'll be sharing all the codes. I'll be doing that. Actually, I saved these all codes in a specific place, so I have to create that document for you. Then I'll be sharing that document with you, maybe in the next class for sure. Share that containing the for instance case study. I'll be doing that as well. I remember that I promised. But you should also be making your notes. It will not be everything through documents, through documents. Okay, so please make your own notes. Okay, so let's begin today's session. Let me share the screen quickly. And again, in the meantime, while I'm sharing the screen, you can please import that data. If you have imported, please run the name statement if that file you imported iLab yesterday is open your importing code quickly. Please import the file. I'm importing the file. Everyone, done. Let's much of time in importing the file. Good. So, what was the pre-test? And you can your data. So mylab dot h is the name of the file. Okay, you can mention not hypothesis. I showed you that if you're going for one sample t-test, whether it is two tail, okay, uh, one tail. If it is a one tail test, either it may be left tail test or a tail test or upper tail test that you can mention using the options. Then you can mention the name of the variable of interest, the variable which you want to check. So math one, I believe it was. And so let me pick this code because some people could save it. So this for them. Okay. And we also discussed about pair test and independent sample t-test. Let's come to that discussion. Can you tell me in this data set any example of paired sample t-test? About what paired sample t-test is, can you check? Yes, you people suggested it yesterday as well. Can go for uh, where uh, the matrix marks of girls and boys are significantly different, but paired sample t-test. test or test? Yeah, independent sample test. What about test? We did. Let me do the independent for you as well. So proc t test data is equal to mylib dot h by, okay. You can mention the name of the variable. It's math1, I believe. And mention class, gender. So it both from the variable which is mentioned after class statement, and then we'll go for that test. So sample t test. I had a discussion about that yesterday, so I thought like I should quickly tell you about this as well. Okay. When we run this, you get two p values. I do have many things which it gives as an output. You need not to look for everything, but p value is something which is important, and you should be looking at that. So p value is coming out to be 0.6801, 0.16, and 0.5845. Last one is of F. This is a result of ANOVA basically. Okay, ANOVA does analysis of variance. The purpose of throwing ANOVA here is to make you realize whether the variance of two are equal or not. So look at this last matrix, equality of variance, and from this matrix you will decide whether the variances are equal or not. If variances are equal, you will pick up pool 0.6601, or find the variance values not to be equal, and you will pick up 0.816 equal variance. Okay. So let's. So Nova have yet to discuss at length, but as this problem is concerned, you can grab with this problem at this instance as well. If you look at the p-value coming out of the analysis of variance, equality of the variance, this p-value is coming out to be 0.58. So we see the p-value, you should always have the null hypothesis in your mind. What is the null hypothesis here? So let me tell you here, the null hypothesis is that the variance of both the samples are equal. This is which you are checking. Okay, so let me write quickly. So hypothesis which you are checking here is of sample 1 and variance of sample 2. Both the are equal. This is hypothesis. So by this p-value, p5845, 0.585. That's it. This block will help you to understand whether the variances are equal or not. Okay. By looking at this p-value, you see that this p-value is number. P-value is a big number. It is 58%. Okay, it's a big number. It is much more than 0.05. So we're looking at 0.05, 5% of p-value, but it is a much bigger number. 0.58 is a very big number. So you will not be able to reject the null hypothesis. In that case, you will hold hypothesis. The null is the variance of sample A equal variance of sample B. Variance for uh, the data of girls, the mathematics marks of girls, and the variance of the mathematics marks of boys. These two values are equal. This from this block. If the variances are equal, then what you will do this block now. Now you would look at first line or second line. Equal variance. So you would look for the first line. This they would look for the p value which is 0.6801. This number. So you would say that there is no significant difference between the mathematics marks scored by girls and boys. How to understand this? Alka, did you derive that the variances are equal? I have been discussing for last 2 minutes. The last block, this one, this actually checks the equality of variances. This is the ANOVA. That is what I've been discussing. So now this is for this F test, for this equality of variances test, is the variance of girls population is equal to the variance of boys population. That is gives you the value as 0.5845. The value is a big number. It is 0.05. Not reject the null hypothesis. So you'll go this hypothesis that the variance of both the girls and boys, the variance are equal. Then you will go for this block. So start with the lower block, this block. There are blocks. 1, 2. You will start with the second block. You will test whether they're equal or not. Then for the first block, this is equal. You pick up the first line, this line, and the value is something which you will look for. 0.6801. Alka, you got it? Any confusion? Any question? It is very simple, but focus. Okay, that was about. Still didn't get it. What did you not get it? Variance of boys and girls are equal. Which field is that? This that test. This is the test for the equivalent of variances. Okay, this is for this. So we will be discussing in terms of hypothesis testing only. The checking the population. So variances you can check by hypothesis testing only. Straightforward way where you will find out one variance and another variance, and then you will see whether they are equal or not. Okay. Problem? Please ask me if you have any problem. Let's not hold it back. Okay. So you people are good. The values, male, female. So code use equality of variance. Yes. Good. Uh, so that multiple values you may have to use something else. No, multiple values 0, 1, 2, 3, 4 will help your cause. Uh, check the of variance for samples as well. Test would fail. Test works only for two samples. Quality of the variances for the population and multiple samples. 2, 6. Uh, yes, estimates of variance. I have yet to discuss that in detail. Uh, so what it actually in Excel if you'll do, it will be very cumbersome for you. So in Excel, I'll show you very quickly. So that's of it. Mm, what you will do, you will get out 0. You pick up this value, and then after that you will pick up for 1 samples separately, and then t test or f test for that matter as well. You can do that. So app data analysis tool pack is there. You can click and then you test whatever test you want to go for. Okay, having this tab in their data tab, they can go to the in Access. They can go to add-in and develop this add-in in the apps. Okay. For independent sample t-test, let me quickly paste this code in the chat box. Now, discuss about paired sample t-test. Yes, I told you, you have same observations. This example yesterday, if I want to test whether the training has gone well, two call math 1 and math 2. So there are two. They will create two. They will make two samples basically. One sample will be before the training, the students before the training, and one sample we created looking at the marks of the students after the training, and then we can check whether there is a significant difference between the mathematics marks before giving training and after giving the training is not. So pre-post analysis it is. So I can do that. Proc t test data mylab dot, and then we mention this keyword paired and math 1 and then egg math 2. You can p-value here 0.1768, and you can to reject or accept the null hypothesis. So at 0.1768, value is again more 0.5. You will null hypothesis. If p is more than 0.05, if it is more than significance level, you are able to reject the null hypothesis. You accept the null hypothesis. Yes. Say the null hypothesis was there is no significant difference but it's marks of the students before and after giving the training. The training has not been effective. Okay, it's about t-test. So we have learned one sample t-test, two sample t-test, but when it comes to able to use t-test, tell me the reason very quickly. This is a favorite question in interviews. I question people who are background to check whether they have actually understood statistics to the core or not. So you have two samples like gender. One sample from males, one sample is coming from females. But if it is race, you have samples 1, 2, 3, and 4. If SEB, three samples. When you have more than two samples, I'm telling you that you can't go for t-test. ANOVA. Why for ANOVA rather than t-test? Can you tell? I tell you what you can do. To confuse you a bit, because notes are very consolidated, very complete, you should be able to answer this question. So hypothesis, null hypothesis here would be like mu1 is equal to mu2, and so third and fourth samples are also coming up, so you can write here mu3 and mu4. So multiple t-tests to check this. You can go for this, then this, then this. Okay, and you have a tool with you. Should not create any problem. So go for multiple t-tests and with some, and you can test this hypothesis. What problem in that? And I'm telling you that you just can't do that. Yes, ma'am. I'm telling you that we don't do that. In that we go for analysis of variance. My question to you is why we don't go for multiple t-tests. So if you are doing it manually, if you are got some calculator and if you are going for the calculations in your piece of paper, but doing it using it would definitely not take time. Time is not at all a constraint. It is not a problem here. We have to test for several permutations. I agree. But why can't we do that? What is the problem in that? Think about. So you should be very clear with what you are doing and why you are doing. So when we got any t-test, okay, so Samya has written here some using the area in the tail every time we do it. Like for every t-test, we compare p-value, then less. You are thinking in the right direction. Hash it. Right direction. Let me tell you what Soumya wants to convey. She's not able to convey it very properly. This is also we need to work on to communicate our technical understanding to non-technical people, or in words, how to communicate the technical outcome in non-technical, in a layman's way. Station of tool as such. So let me tell you, whenever you go for, so this we need to practice. Create the technical outcome. So your mind will be thinking in mathematical ways, but the people who would be taking the decision, they want it in terms of business. Whenever you are going for any t test, okay, go for some of rejecting or accepting null hypothesis. If rejecting null hypothesis and it is actually true, okay, then error is not even true. You always carry some error with you, carry some risk with you whenever you go for any decision. One error or it might be type 2 error. So you carry along some error with you. Okay. If you go for multiple t tests, one situation, here check whether these population means are equal or not. Multiplying the errors, the error, the increasing. So by the time you will make a decision, you have a big error with you. You carry a big risk with you. Okay. You don't go for multiple t tests at one instance to avoid the error. Okay. So in that we have other technique. We the analysis of variance for analysis of analysis using t-test. We'll be going for analysis of variance. We will look for the variance values. That is much better way. It is much more efficient way of finding out whether this hypothesis is true or not. Okay, so it's time to learn a technique, a technique which is useful in uh, more than two samples. Okay, you have more than two samples, and you need to check whether there is a significant difference between the populations or not. Then go for ANOVA instead of t-test. So this would work for one sample. It will work very well for two samples. But when number of samples become more than two, you go for an analysis of variance. Anybody, any confusion in this? This is very simple. Okay. So let's understand what is ANOVA, and then let's use that. Just give me a sec. In the meantime, you can ask me. you more than always analysis of variance, that is 5 or 6, for instance. Yes, whenever you have more than two samples, 3, 5, 6, always go for ANOVA instead of t-test. So in sample, you will go t-test. If you have two samples to come, you will go t-test. It may either be independent or it may be paired. Have three samples for for will go for ANOVA in that case. You will again go for ANOVA. 5 ANOVA, 6 samples ANOVA. Okay, so whenever you have more than two samples, you will always go for ANOVA. What's in ANOVA? What does ANOVA do for you? Just a moment. No problem. Abbreviation for analysis of variance. ANOVA. AVA. ANOVA. In action as AOV. So some people as ANOVA as well. Okay. So it varies from one book to another, but in most of the books I have seen ANOVA. ANOVA. Okay. Can you see the screen? Uh, uh, Possible to you? Okay, thank you. So to make it very simple, uh, the mark of three schools are okay mentioned in the same subject by three students belonging to different schools are mentioned below. Does suggest any association between the schools and marks? I want to check that. So here that there is a significant difference between the students or not. So check that. Go about that. I'll tell you the intuitive way. Then I'll take you to some mathematical calculations very quickly. Into mathematical calculations a lot. In case of ANOVA, you have three groups, three samples, 1, 2, and 3. Here you find out the ratio of between between variance and group variance. You show this ratio as an statistic within group variance and, and group variance, and within group variance you and you take ratio of both, then you decide whether significant difference between the populations or not. You do. So we Z statistic, we learned T statistic. Now it is F statistic. This ratio is called as F statistic. Let's understand it first of all intuitively, because we all have understood the concept of variance. Okay. So we will go for the calculations as well. So variance, what does that mean? So variance means you have these groups, finding out the variance within each group, within group, within B group, within C group. That is called as within group variance. And if you talk about between group variance, it will be like this. Between, okay, you know that if are coming from the same populations, significant difference between the three groups, it simply means that they are all from the same population. Then what about this ratio between group variance and within variance? Coming from the same population, what be this ratio? Yes, coming from the same population, group variance would be very close to group variance. Okay, significant difference, it will be very close to 1. But if a significant difference groups, what would be F value? Will be what from 1 between group variance would be more than, okay? Yes, it will. Okay. So F statistic, you find out this way. You have found out F statistic. From F statistic, you can find out the p value, and then finally, by looking at the p value, you can decide about the null hypothesis. This is what you do in analysis of variance. That was intuitive way. Quickly take you through the calculations. Let's try to understand the calculation part very fast. Let's not invest a huge amount of time in the calculation part. The objective is to find out within group variance and Billions. These two things ultimately we need to find out, because ultimately we need to find out the F statistic. There are some steps which uh, followed by the students, but I'm telling you these steps so that you can have a feel of it. So what we do as a first step, we'll find out the group means. So for these three groups, A and C, will find out the group means: 82, 83, 97, 83, 78, 68, 38, 59, 55. These group means you will find out as a first step. Step, you will find out the grand mean, that be the mean of all the numbers, and after that you will find out the sum of squares with group and between group. Where within group and between group you will find out. So let's talk about second point. I'll come to first point. Some square deviations of the group mean about the grand mean. So what do? We'll find these differences and then square them up, and you find out the sum. So 71.4 minus 87.3 out of that. 7.4 minus 76.3 is out of that. 1.4 minus 50.6 square, and then the sum of squares between. So that will be your between. So that give you the sum of the square. If while running of variance, we did the same kind of thing. We found the square deviations and then up those deviations. Okay. So find out sum of squared deviation a big group. For group, what we the sum of square deviation of observations within a group about their group mean. Now we find out the group variance. For that we have to care about this number. We will only be caring about individuals. So 87.3 minus 82 square, 83 minus 83 square, 897 square. The C will do for school B and then school C. That will give you sum of square within groups. Not sum of square within group and sum of square between group. Okay. You get out the total deviation as well, summing these two up. So of square deviation about the grand mean across all observed value. So if you will select all the values 82, 83, 97, 83, 78, 68, 38, 59, 55, all these values, uh, 7.4, that give you, and then you will square them up and sum them up. That will give you the total sum of the square. So three terms you will find out, and after that, what you will do, sum of square between the corresponding degrees of freedom square within, you will divide by the corresponding degrees of freedom, then the variance. You can mean sum of squares as well. Sum of square as well. This is actually the variance. So within column between column variance and within column variance ratio, you'll find out F statistic, that will be, and F statistic, you will find out the value of P, and P value you can interpret. This is how you go about. Anybody want you to feel of it? It was very much necessary. This was given you the of what we do in ANOVA. Degree freedom, I never wanted to take that up. Yeah, I wanted to take that up as a concept because it is a very mathematical concept and it has been taken care of by the tool only. But let me quick explain you what degrees of freedom about. I'll be discussing about the calculation part, and I will always avoid to look at and degrees of freedom. It is very statistical, mathematical thing, but I'll give you the idea of what it is. You have four numbers: x1, x2, x3, and x4. Okay, and you have been that the sum of these four numbers is equal to say 24. Okay, and all these x1, x2, and numbers, they belong to real set. Numbers are real numbers. Okay, uh, I have decided about the values of x1, x2, x3, and x4 equation. Okay, so I have to decide about the values of x1, x2, x3, and x4. Can values x1 can take up? Are I believe to understand what real numbers are. So these are all the and irrational number, all the negative, positive numbers on the number line. Minus 10.5, minus 10.26, 0, 1, 2.5. These all are real numbers. So many values x1 can take up? Yes, infinite number of values. Yes, any value. Uh, the sum to take any value on the number line. It can take up 1 million. It can 1 billion. X2, X3, and X4 are yet to be decided, and we can accommodate the values of X2, X3, and X4 according to X1. Take up any number of values. So it has the freedom to take up any number of value. So I have fixed the of X1 is now fixed. Now let's do X2. How many values X2 can take up? Any number. X up any number of values. X3 can again take up any number of values. But now when X1, X2, X3, these fixed, can you tell me number of values X4 can take up? So now you do the option for X4. Sum needs to be equal to 24. So X1, X2, X3 value. So now you see from this discussion that you have four variables. Then the sum for three is only three values, three variables. Okay, n observations, the degrees of freedom become n minus 1. Variables and multiple observations have different ways of calculation of degrees. I will never be getting into the calculation of degrees of freedom because that will be No, that be very useful for you people for sure. It is typically be calculated within the tool and to look for that. But feel of what the freedom are. So about ANOVA, we get into the action part. Can you tell me scenario? Can you tell me in which scenario we can use ANOVA here? More important. That is very, very important. You should be knowing videos in which you will be using a particular technique. That you should be well versed with. So, I agree with you. At a unique set of numbers like 2000 here, the groups, observations here. Two groups it will form. Uh, versus math one, which like more nominal variable, it is nominal variable. Nominal variable. Let's talk about uh, versus math one. So is here. So check whether there is a significant difference between the mathematics marks of these four courses or not. That can check using ANOVA. So ANOVA is again uh, you can use proc ANOVA. You can use SEB as well. Proc ANOVA data to mylib dot hip. Okay. Then variable class variable is race. You can model. In you mention the numeric variable, the variable of interest, that is your math one, equal to that you would be using in ANOVA. And what will be your decision? And see the values. So it ought to be very small. P, the P ought to be small that it can't be written here. The value ought to be 0.001. 001. It isn't 0.0001. Okay, so I can say that there's uh, a second difference in the mathematics marks of these four races. Have to reject the hypothesis. Any yes, already you can look at the f value. Okay, but you need to compare this f value with critical f value, which is derived from the p value with the probability value, because you need some benchmark. Value is 7.7. It is a big value, so it simply means that the between group is much more than within group variance. Okay, but you again need to compare it with some value. Look at p value. We can directly compare it with 0.05. What is the relation between f and p? So again, f statistic is again a curve. From that curve, you can find out the probability value. Again, the area under the curve. Find out integrating different intervals. So that's about ANOVA. Let's talk about chi test. Less than 0.05, so that if p been 10, we would accept it. Yes, p would be 10 though, because probability value, which will always be confined within 0 and 1 or 10%, 0.1. You are right. Yes, you are right. Okay, let's talk about chi. To make square test, again, I want to discuss one case study to make it very clear to you. I'll take you through some mathematical calculations as well. But let's focus here. Let's concentrate here so that we don't spend a lot of time here. You to have a feel of it. Like now, if you look at now PF value, you have to intuitively understand what this value is, what is between group is, what is in group variance. Now you have that feel. That is I want you to have here in case of chi-square test. So I want you all to read through this case, and I'll have a discussion quickly and read through this paragraph. So case is about a nuclear plant. City has a newly opened nuclear plant, and there are families staying very close to that plant, dangerously close to that plant. A safety officer want to take this case up to provide relocation for the families that live in the surrounding area. To make a case, he proved with numbers that an exposure to radiation levels is linked to an increase in diseased population. So formulates a contingency table of exposure and disease. Contingency table means you have frequency values, you count two variables together. Explain you what this table is telling you. So this is telling you there are 37 people who are exposed to nuclear plant. So exposed to the nuclear plant means they are living very closely. They are living dangerously close. And so these 37 people are living close to nuclear plant and they are found to be diseased as well. But there are people who are close to the nuclear plant, they are not found to be diseased. And impact. So radiation had on these 13 people. People who are not at all nuclear plant, but still they are found to be diseased. There are who are exposed to the nuclear plant, nor he to be diseased. So this is the interpretation of this table. Do not understand this table. Great. So all so you all have understood what this table is all about. Let me these numbers are called as observed frequency numbers. So these are observed frequencies. Frequencies you observe on the ground, on in reality. Okay. Attention here. 5 minutes. Okay. See table which is containing the observed value. What do next? We will find out the expected frequency tables. Expected frequency values for that table. Let me questions here. Just a moment. Heart disease. Answer. What is the disease? Yeah. Uh, it's which is prevalent when we stay near nuclear plant. Okay. Yeah. So they have those diseases which are very frequent, which are very often with those who stay near the nuclear plant. Yeah. You estimate the statistics for an entire population based on this sample. Yes, you're right. Basically, we need to understand whether this data is suggesting any association between disease and exposure. So you must have seen through this data that it is difficult for you to make a statement about anything. 120 people, and out of 120 people, the people are having and numbers. That 17 people who are not exposed even, and they also caught of disease. So a strong case. So you need medical treatment of this table. Basically, the hypothesis which I want to check here is that uh, an association between disease and exposure. Okay, so basically it is about let me write it uh, that these variables, disease and exposure, they are independent of each other. So this is also called as the test of independence. Let me write here. Uh, Dependence be done in t-test. Dependence it is called as, and H naught here is disease, exposure. Diseased and exposed are not associated with each other. This is hypothesis which you want to check. And exposed, there are two variables, diseased and exposed. I want here the hypothesis that diseased and exposed are not associated with each other, because data would be something like this. You have respondents, they will have exposed, there will be people which will have diseased. Like my yes and yes. It will fall in this case 7. Okay? A would be one of those present in the 7 people. Yes, Brenda. Must be some definition of exposed, that people who are staying within 5 miles of the plant. Okay, is giving you the broader picture. The analysis, this survey must have been big one. So far, so the question which Brenda is asking, it's a very genuine question, a good question. I faced these type of problems, these type of questions in my presentations to the decision makers. I have faced these kind of questions. So that I'm saying that this question is important question to answer. She's saying that there are many other factors that might be the sickness of those people. uh, nutrient that to right away let you is done for variables only. It is not done for the character variables. Interest must be numeric. Chi is always done on the character variable. Quickly answer her question as well. So let me tell you, Brenda and everybody, there may be several factors, and that's why we are doing this study. Okay, you need to consider variables are character variables and to test the also to character variables. Okay, those may be called as character variables. That may be called as quality variables. Those may be called as all variables. Okay, norms. So different names which I have already discussed with you. And you want to check whether there is an association between the two variables or not, then we checking it on the sample. Okay, and then we don't care about other factors. Result takes care of that because tells you whether there is an association or not, and it's the degree of association. From the you will find out the p value. It will you they are associated with each other. So you need not to care about rest of the factors. Okay. The best thing about these hypothesis tests. So worry about the causality as such. Okay. To uh, the decision of case, how we will proceed. So these are observed frequency numbers. We need to get the expected frequency numbers. Then only we compare. Can you what do I mean by expected frequency numbers? These are your frequency number. What do we mean by expected frequency numbers? So you should now connect the dots. Connection of dots are very important. Uh, what I mean by expected frequency numbers? Expected numbers, I mean that numbers again not finding out the probability. Again frequency numbers I'm finding out, but those frequency numbers should be now according to null hypothesis. The null hypothesis is that these two are independent variables. These two independent things. They are depending on each other. If not depending on each other, what would the number be? Let me quick here. 37, 13, 37, 13, 3. Observed. You have yes, no, no. This is for and is this table. We're trying to phase expected table. Table, I mean to say the values the hypothesis. The hypothesis is diseased and exposed are not associated with each other. With each other, it simply means they don't have any impact on each other. Okay. So thing here is they have any impact on each other. The well or multiplied by 50 divided by 120. Very basic proportion concept. If they don't have any impact, the value, think of it and let me know. If you don't agree, if you're not able to understand, I will explain you in detail then. And it would be 4 again into C divided by 120. 60 divided by 70 divided by 20. If they are independent variables, impact of exposure of plant on the disease, then the numbers would be like this. How many of you agree with me? Understood? So anybody, Anjan has understood? People are able to understand it. Prasanna is not able to understand it. So let me quickly explain you. I'll rephrase my statement. Mm, 15 into 120. 50, 70 divided by 120. I'll try to rephrase it. Okay. And disease. These two are independent. Okay. The disease of these will in the proportion. So let me do one thing. Let me show you in the slide. Those and this is the I understand. So what you know is the proportion of population exposed. So there are people who are exposed, people who are not exposed. So basically 42% of the people are exposed and 58% of the people are not exposed. Uh, is not causing the disease, then the total diseased people are 54 total diseased people. They would be distributed in this proportion only. Don't you agree? And without disease, there are 66 people without disease. They should also be distributed according to this proportion. These two variables are not related, they are independent. Now you agree with me, Prasanna? Okay. Basically, you get to all frequency table, then finally what you do, you do this value, observed frequency minus expected frequency. For each column, you will do that. Expected is square. Let me show you. All this is expected. So observed minus expected frequency, the square of it, and you divide it by the expected frequency for it. And then you come up for all the cells. They give you another statistical parameter, another statistic that is called as chi-squared statistic. As chi-squared statistic. Statistic, learned T statistic, we learned F statistic, and now about chi-squared statistic. Squared statistic. Again, you will find the p-value, and p you can decide about your result. Okay, wait. Let's data set. This data set race and gender. These two are two categorical variables. These has two categories. Race has four categories. If you want to see gender and race are with each other or not, if you can go for chi-squared statistic. The is very easy. You have already done that. Proc-frec you will be using here. To my lab dot hyp you will ask will all to write here CHISQ. It the test dependence for you. but character sample is considered for chi-squared. Yes, what I said. So you have two categorical variables here. Genders, these are two categorical variables. As you can take up, program take up, categorical variables, which is containing some categories, then go for chi-square test. So chi-square test basically helps you find out the test of independence of two categorical variables. So his square test, this is the first one you need to look at. Chi-square is giving you some other things you never asked it to do. So zero point 0.6 is the p-value which you can compare with 0.05. It comes in 0.05. You will not be able to reject the null hypothesis. You would say that these two variables are independent of each other. They are the association variables. Are you getting it? Right. Question. Okay. We have understood the test for this instance. Why would you use t-test where you have the variable variables only? Uh, 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 of the fact that we have learned t-test starting off with the normal distribution. In normal distribution, I told you that this distribution is for the continuous variable. From there, we learned the z statistic, t statistic. Okay, so over there was about the continuous variable. Mathematics marks were there. Discussed about results, those kind of things we discussed about. Okay, so it's only for the continuous variable. Whenever you have the continuous variable, then only you go for t-test. And for f-test as well. So when groups the const values of the variable, then you go for z-test and f-test. Chi-test is the only test which for categorical variables. Confusing that if you are facing some problem, please let me know. I will try to explain it in a different way. But there's confusion in that. Uh, get to contributes again, and let's understand a concept of correlation. It's a concept sample. It works. Oh, talking about gender and race. We are taking only one sample. In that sample, we are checking the test dependence of these variables, gender and race. that yes, these two are not it. These two are independent. They are not associated. Very simple thing. So this is the sample. A lot of observations are there. These observations in that sample. How many are there? Just a moment. Observations. So sample size would be 200. You are getting Junath? So say 200. This is the whole sample. One it is. Contains all the students. I mean, please let me know if you have any further confusion. That. Not. No, no. You people are getting confused. Let me help you with this. Let me do one thing. Let me stitch everything together. Discussing about sample t-test. We problem statements were different in all cases. So, one example, let me quickly help you with this. One sample t-test when we ran, we went for only one variable, one, and we had the hypothesis like that mu is equal to 54. One sample. This is one sample in that whether the marks for the group of people are equal to 50 or not, whether they are slightly different from 54 or not. So based on our hypothesis was that the mathematics marks for these people, these type of people, not significantly different from 54. So the sample we got for all these students and we checked for that. When for two sample, I do the sample of paired sample, example of independent sample. Sample, I told you that we can test for these students. So multiple tests were organized. So for these students, I can check math. What are the records which are telling you they opted before going training. Math to uh, records of the numbers obtained by the students after going through the training. Then samples, one sample you are getting both the training and after the training you are getting math two, not two samples. In independent, in case of independent, one getting for 0 for male and 1 sample you are getting from female for the same variable. But in all the three scenarios, whether it is paired or independent or it is just one sample t-test, of interest has always been a constant variable. Math is a continuous variable. When test, again, the variable of interest was a continuous variable, math 1. But the samples you say, so the samples. So this sample was divided into 4 samples. We talk about the race. There are 4 races. But in case of chi-square test, we want to test the 2 sample. So this is one sample. It can be divided according to different categories. Manjuna, am I clear? Am I making sense now? If so, now with hypothesis testing. Uh, let's discuss very quickly correlation. What is a correlation? Let me plot. Uh, do you have other example for categorical variable? Yes, I have thousands of examples for categorical variable test. You have uh, uh, days, okay, and the ratings are given in one column, locations are given in another column. You want to test whether there is any association between location where work it's result. That will be a chi-square test. Are you getting? So, suppose you have yes, Krish, uh, make example better. You have a for people and you have educated. You make the criteria for educated and uneducated. If somebody is beyond metric, that person you can consider as educated, less than metric. You can call that person as uneducated. You can test all the people. And the third column, you may have uh, uh, east and south of the country and check whether education region are with each other. Am I making Yeah, good. Good. Created this scatter between the price and the living area. Create this plot. I want you to have a look at it and get into the discussion. Because I've seen so far that business understanding is the thing. You should be able to relate your graphs with the business because ultimately you're helping some business. What you can from this graph, let's that you can trend that you need to you would on the axis we have living area and the y axis we have price. X axis we have living area, we have price values. It's a generic trend, might be true for all the observations, but you here for lower values of living area, you have lower price values, and for values of living area, you have higher price values. So as living area is increasing, are increase that. Okay. Again, we are talking about yeah, much a consequence which we want to measure. Other variables will also show you that like this. If you, whether variable A and B are related, variable C and D, how will you go about that? We need to learn here a term called correlation, and this uh, just a moment. This measured use correlation coefficient. Correlation coefficient, yes, coefficient values lie between -1 through 0 till +1. Values lie from -1 to through 0. If the correlation coefficient value is very close to 1, it means they are very highly positively correlated. In this case, value of correlation coefficient be the correlation coefficient value will be close to 1. So variable A and variable B are moving such a way that if it is increasing, they're affecting the increase of B. Okay, so we both are increasing together, then the coefficient, the correlation coefficient will be positive, and that will be close to 1 if the degree is high. A is increasing, but B is decreasing at the same time, then correlation coefficient will be negative. And if the degree of if the degree of association is high, then it will be very close to -1. Okay, I'll show you another graph. So now the correlation. So here, this particular scenario, the correlation coefficient is out to be 0.77. Therefore, living area. Okay. Let me quickly draw another diagram. Now pick up, say, age. This I'll pick up age and y-axis. I'll keep price. So a big trend. You can observe, uh, you know, that lower of age, the price, and but age values, you say low price values. So that is a bit like this, but it is not very prominent. There is some correlation, but the correlation is not having a very high degree that you can infer looking at this graph. That correlation coefficient, whether it is also speaking the same. So price and age. So with the price, you can see here it is giving you a negative correlation. It is telling you that price and age are moving in opposite direction. If the age is more, price uh, low. If the age is small, the price will be high. So for new houses, prices are big. For old houses, the prices are small, less. The association, degree of association is not very high. It is negative. It means that the variables are moving in opposite directions, but the number is very close to zero. It is not close to -1. So the degree of association is very small. That is what is given by the correlation coefficient. In this, so what I wanted to discuss about correlation coefficient. Let's find out the correlation coefficient of variables. Pick up some data set. Help. I only show you how we in SAS file. Here, right, we have age and weight as well. It is the correlation between and height. So Procor data as help jobs. You can mention as many number of variables as you want. Let me put it and HEIGST height, and let me paste it in the chat box as well so that you can also run the output. The output you several values. Done already? Quickly interpret these values. What these all values are. Interested in the lower block. The block is only giving you some statistical descriptive statistics, mean and deviation, sum, minimum, maximum for these two variables. Let's discuss this part. So grid. The coefficient between age and age, it is 1, which is obvious. And height and height, again it is 1. Between age and height, it is coming out to be 0.81143, and the same obviously will be for height and age. So it doesn't matter, the permutation will not make any difference. Combination is important here. 0.8 is the correlation coefficient, so it simply means that they are positively correlated and the degree of association is also very strong. This coefficient is very close to 1. Let's about this 0.001. What is this? Let's answer this question and go for the break. So can you about what this 0.0001 is? Definitely a p-value. P-value, but should be able to understand what is the hypothesis test. What is this? So null hypothesis is also mentioned on the top of this block. This here is there is no correlation. They are not they are independent. So this is that the coefficient of correlation is, so you that the p-value is coming out to be 0.001. 0, 1. So you will reject the null hypothesis and you will say that these variables are highly correlated. What relation? For relation, mathematically you can easily find out on Google. It will be covariance divided by both the square root of both the variables. Okay, easily find out on Google. That is not required here. For then the covariance as well. That's why I divided. I did that and required as well. And good. We have now understood the concept of correlation as well. After we'll starting off with regression, a very statistical technique. So let's meet right after 10 minutes. Please part in the polling activity as well, which I'll launch right away. questions from everybody who are back the session. Neeraj here. Okay, let's start the discussion now. So we have understood from correlation that correlation coefficient you the degree association between the two continuous variables. You understand how two continuous variables are associated with each other. Okay, but it will not give you answers to many questions which I'll be putting across it. Because it is talking of only two variables at a time. If variables, so you are talking about price and living area. It is giving you this information that price and living area are moving very good with each other. If living area is increasing for higher values of living area, you have high price values. Information you are getting, and for lower values of living area, you have lower price values. This is something you are getting from the correlation coefficient. But to to a question like what be the price uh, is uh, suppose living area is 1500, what would be the price of that house? If I'm asking you that question, how is that question? Extremes, what do you mean say by extremes? So I'm says Brenda, it might some more information like location like things, but have this limited information about answering this question. Suppose you have only price and you have living area, only two variables you have. And based of these two variables, you want to give answers to some questions, and this will be the case. Yes, you get the answer in terms of the range as well. I agree. Okay, but go about that. A coefficient will not be able to help you in that case. You need a technique which may the two values together. Okay, technique which can relate two variables together. If you shift between the variables, then you will be able to answer that question. So regret is the answer to those questions, if you know how to run a regression, you will be able to find out the answers to those kind of questions. And basically, uh, the variables are related with the other. It forms the equation. It gives you the formula how two or more than two variables are related with each other. For example, if you could get an equation something like this, that price is equal to uh, plus beta area. If you get equation something like this, answer this question. You will living area. Yeah, it will give you price. Okay. And find out. Regression is a predict analytics technique. Help you to predict the value for any variable of interest if you relate it with the variables with the fields which are impacting the variable of interest. Okay. Take you through the procedure. This regression on height. We'll have a discussion of the put and learn further. So proc we will use here is SAS help dot class. A small just try data set so that we can then we can pick up some big data and apply that. More, you will make the table. Suppose you are considered and want to see the impact of age on height. Height. Yes. Now let's understand various terminologies. Foremost, what we are doing here is about between height and age. Height is considered as a dependent variable. What I mean to say is create model and model if you are mentioning the dependent and independent variable, you mention dependent variable at start, you mention dependent variable, then after equality you can mention all the independent variable. So if regression we are here, uh, if we are trying to derive the equation something like this, price would be dependent variable, living area would be independent variable. So we predict the price with help of living area. That is the whole objective. It is as dependent variable and it is also termed as predicted variable. Area is called as independent variable and it is also called as predictor variable. So these terminologies. So independent variables are also termed as regressors. Independent variables is also termed as regressors. These are as predictors. Okay. You answer to your question, Manjunath. What is uh, interpret what this output is all about? So we will each and everything step by step. We need to understand this whole output altogether. So here, the the more independent variables as well. When you have one independent variable, it is called a simple regression. When you have more than one independent variable, then it's multiple regression. Okay, it can be linear. It can be non-linear as well. So let's start a procedure where model is giving you that the dependent variable is height, number of observations read are 19. Then you have this analysis of variance table, which is not new to you. So we would only be looking at the p-value, but what this p-value is for, this is something we need to understand. Why we are running analysis of variance in regression? This understand. Of variance in regression, we want to test the hypothesis that the uh, and variable age, they are not related with each other. They are not related with each other. The coefficient of independent variables would be equal to 0. That's something we are checking in this analysis of variance. Checking here is that if like this, uh, height is to alpha plus beams e- suppose the variables as well. This is beta 1, beta 2, beta 3. So what is of variance checks here is beta is equal to beta 2 is equal to 3 dot is equal to 0. This being in of variance. Not related with each other, it simply means that coefficient will be equal to 0. Very first thing you will do in regression, you first of all look at the output of analysis of variance, and then from where you will start the discussion. So analysis in regression is done to check the overall feasibility of the model, whether the overall model exists or not. If the model does not exist, it simply means that beta 1, beta 2, beta 3, all the coefficients would equate to 0. There will be any relationship between the variables, between the independent and dependent variables. P value here comes out to be 0.0001, which is way too less. So if you look at 0.05, you can always reject the hypothesis and you can say that there exists a relationship between dependent and independent variables. Not understand this point. It is important to understand the analysis of variance here. Explain who could not understand this point. So C is equal to 0.0001. Less than, it is less than that. So you can say that you can reject the null hypothesis. What is being tested here? That thing you need to look at. The null here is there is no relationship between the independent variables and the dependent variable. There is between height and age. This is what you are saying in H naught. If there is no relationship, it simply means the coefficients are 0. Beta 3, all the coefficients are 0. You have only one variable. If there would have been many, all be equal to 0. This is what you check in analysis of variance. But P value is very small, you can reject it. You can reject it. You can say that no, there is some relationship between variables. So you start with analysis of variance by checking the overall feasibility of the model. Am I making now? Brenda? Good now? Anyone? Yes, it is. Keep asking questions. Regression only I told you. Suppose you have age, you have weight as well. So beta 2, weight. So it's useful when you have multiple regression, you have multiple independent variables. So it says that all the coefficients are to 0. Beta 2, beta 3, beta 4. All there exists no relationship. There is relationship existing between the independent dependent variable. That is what you do analysis of variance here in regression. So your value should be equal to P less than 0.05 to go ahead. Niranjan. So then 0.05. That's very clear. If P value is less than 0.05, then you can say that not all the independent variables are related, not though at the same time. That is you can say. So the alternate hypothesis is not all are zero. Not all. So less than 0.05, you can say that not all zero. There exists relationship between the dependent and independent variable. Is it making sense? Not I'm talking about. So good. We are on the same page. That's great. So now come to the next one. Anybody in the analysis of variance part in block? Anybody? Any question? Okay. You all have understood why we use analysis of variance in regression. You should be able to answer this interview question. That analysis of variance in regression is used to check the overall feasibility of the model. This is in case is about all the coefficients of the bills. All coefficients are simultaneously zero. Is what we check as a hypothesis in analysis of variance. If the value comes out to be less than 0.05, then we can reject the null hypothesis and we can say that not all coefficients are zero. There are some independent variables which are related to the dependent variable. Okay. Or else add one more. Let's say WEIGST. Let's add weight into that. Then it becomes regression. Pasted the code in the chat box. Uh, Talk about the second block, which is very important. But that let's discuss about the third one. Between independent variable zero. Yes. ANOVA, here we are using to test about the coefficients. Right? Finding out the relationship between height and age. The relationship would look like this. The beta naught, this is a constant, plus 1 into beta 2, sorry, weight. The ship, you might, what else? Height and if they are not related, then beta 1 would be equal to 0. And if weight and height are not related, then B2 would be equal to 0. Okay? Are you getting me? Or yourself? So overall model. So check for beta 1, for beta 2, for beta, for all the coefficients, and it check whether all the coefficients are 0 at the same time or not. If coefficients are 0, if value suppose comes out to be say 0.5, out to be 0.5, and the P value would have been very high. Then you proceed for further analysis. It really says that all the coefficients are equal to 0 and there exists no relationship between the independent and dependent variable. Okay. A is not dependent. So we about the relationship between age and weight here at this point. If you want to mention something else, we are discussing the relationship between the independent variables. We are saying at this time the relationship between dependent and independent variable. We are not discussing the relationship between age and weight. Session altogether. If this would have been 0.5, then you would have you would not have been able to reject the null hypothesis. Okay, proceeded further. So that analysis of variance and why we use that. So the last uh, block we went into the second block. Second block will take some time. After we are done with the third block, we will come to the second block. It is very, very important. So see in the third block, T test being performed and looking at data p values. To we perform T test. Understand why? And you can see here 3 tests being performed. Why we are performing T test? I simply mean that you need to come with a null hypothesis. What would null hypothesis here? Test. Right. That trying to uh, that is more important. Yes, so people are not able to connect the dots. That is more important. So test here we have three t tests. T test is for intercept. It's intercept is equal to 0. First t test is for second t test is for the cough age. So the second t test is as in rest of the people. We appreciate your response. You all mentioned that there is no relationship between age and height, the dependent variable. No relationship between height and age. This is what you say in the null hypothesis being stated for this t test. If the relationship, it simply means that beta 1 is equal to 0. This is which is being tested here. B equal to 0, there is no relationship between weight and height. They tested here. The P ought to be less than 0.05, then you would be able to reject the null hypothesis. Otherwise, you might to consider uh, uh, taking that variable out of the analysis. Okay. So in this case, all the values are coming out to be 1.05. So what you can say here that there is a relationship between age and height, and also say that yes, the relationship between weight and height also exists. So negate these two null hypotheses by looking at the p-values. So we'll consider age as well as weight in our equation. The equation which you will derive would look like this. Coefficients basically. So is equal to 8.11932 1 plus 1.22 multi age 1 point sorry 0.13 multi question you derive. Basically they're not doing that, uh, but basically you would give this kind of equation. Anybody? Inter constant part. What you can do, height is equal to age space weight, then colon. Give the space and then you can type weight. So test the intercept is equal to 0 or not. Okay. Intercept is, let me tell you, the constant term. Okay. Is any question? So give me 5 minutes. I'll be explaining it in detail. Uh, ask If you have any question with I've done so far, don't have to write everything again and repeat those things. Any have from what I've done so far? Have to discuss a lot. Residual and all things are yet to come. A long discussion. Regression is very simple. We get into a lot of discussions. Just wanted to discuss the output side. That's why I'm running this code. Yes, in regression on real life data as well. But then regression are on a complex side. So they're a bit complicated. So that's why I'm giving it a lot of time. Yeah, we process. I've already discussing. I've already discussed that thing with you. If the p value here comes out significant, obviously you'll not take that variable into the regression model. These big when you are a student, when you do it in your MBA classes. These things will not trouble you a lot when you will be using the tools. So I'll definitely be telling you these all things very quickly. Requires a lot of practice. So you practice it, bring all the concepts. We don't cover in regression that covering in dysenteries. Will future courses a case of time series not included in the program? I could not get your question, Razika. Yes, please. Question. Okay. Any question? What we will we be working on modeling case study using regression? That 1 minute back, I told you, these all things will be covered with the help of a case study only. But you have to practice it. I'll be covering everything as a concept. part of the discussion in of decision trees. Addition, not inner. That will not be the part of this discussion in SAS. A base theorem. I discuss other machine learning concepts in my R classes. Okay. Sir, uh, regression. So what we do regression. Let's now discuss about the conceptual part in detail. Since we've seen the output as well, be able to relate with the things in a better way. So I start off with the simple linear regression. Uh, Here, it's a very important concept. It to reiterate time and again. It will come be the waste of the time then. Except we have a living area on the have price diagram, but uh, we have to find out some relationship between price and living area. Tell you the exact relationship would always be difficult to find out in a life scenario. This is a life data set. Okay. Uh, Shape will be very difficult to find out, but yes, we find out a relationship which can give you the ballpark figures for the predictions. So, basically, like to put a line here, simple linear regression can represent the relationship between price and living area the best possible way. In linear regression, once we'll be able to develop a relationship between price and living area, we would be able to predict the values for price. Okay. How about that? So can be written as price equal to, if this is your intercept, you must have heard about intercept and hope in Centauret is standard. So if your intercept is suppose beta naught, you can write as beta naught. If hope is beta 1, you can write 1 into living area. That's what you do out as a relationship. In the is the intercept. Beta 1 is the slope. Might be worried about what slope is. So slope is the tan of the angle, the line and the positive x-axis. Okay, that is, you basically try to add this kind of equation. Let's take any point. To equation, the biggest problem is the points are lying on this line. Basically, need to optimize this deviation. These all points must be lying on this line, which is not the scenario, and you will see this scenario anywhere in any real life data set. So what do you try to find out these something which always want very small. So draw a to make it better for you, visual better for you. I'm picking up this. It should be lying on this line, but we are way ideal scenario. So if this is, it should be on this line. Okay, this point as y hat. And y hat. So this is something which is called as a residual value. Error as well. Some is not able to x y minus y hat. Or try to minimize it. What I'll do now, I'll take up this y minus y hat value, this difference for all the data points. And I will sum up all differences, the residuals. The sum of residual. Can you put this be if we have the ideal uh, equation of the line? Seen this thing in the past as well, multiple times, that this would be equal to 0 because you will have same number of points above the line and same number of points, same kind of distance below the line. So this will be equal to 0. But somehow we want to measure this residual, this distance. So what we do, we can do the same thing. We find out the square of it, and then we sum it up, and then we create a function out of it. That's a function. Create the function of it. Will be in terms of b naught, beta 1, and whatever coefficients you have. Don't think so? What is y hat? Y hat is the predicted value. This is also called as predicted value. This is okay. This is the x value. So the between predicted value and the actual value is called as residual, and you find the score of the residuals for all values, and then you sum those all residuals up to find out a function. This function will be in terms of beta naught, beta 1, beta 2, and all. How will that be? So you are actually getting this equation y is equal to beta uh, 1 x1 plus beta 2 x2 dot dot dot. If you want to find out y hat, you need to put the value of x. The value is x here. Is x. So beta x beta naught. This equal to hat to y hat, and will subtract it from the value of y. You will you have to sum it up for all the values of y, then get a function in terms of beta naught, beta 1, beta 2, and all. You next important thing, you minimize this function. So in ninth standard, or I believe in 10th standard, we learned maxima and minima. And maxima and minima, we learned that to find out the maxima and minima, the derivative, and we equate that to this we do as the first step. I will not be taking you through the differential calculus for sure, but I'm telling you how it is done. So it is minimized, and in the process of minimizing, you get to the values of beta naught, beta 1, beta 2, beta 3, and all. Only by the tool, and in those all values. These estimates are those values only. Okay. That it is also called as ordinary least square method. So this is the basic algorithm behind linear regression. So it's called as ordinary least square method, or as least square method. So you find out the square is residual values. You sum up all the squared residual values, and then you find out the minimum of that. In the process of finding out the minima, you derive the values of beta naught, beta 1, beta 2, these are all coefficients. Anybody? The discussion further. Well, ordinary least square. Some of the squared residual values. So the squared residual values. Okay, let me take the discussion further. Here, let's see what regression has done for you. How much regression to as a variance. So how much variance, how variation in y is being measured with the help of regression. Let's understand that part. Would not have been any Peter if there would not have been any rigor, if there would not have been any independent variable for that matter. For predicted value of y, you would go on for the value of y using y y. So now I'm plotting y bar here in bin. Okay. So the value of y is this. Okay. The value of y is this. Would not have considered any parameter, any factor which is impacting the dependent variable y. And for that variable only is the only way to go thing which we have achieved through regression. We are able to bridge the gap till this. Value of y is this. Total deviation is this. Deviation from y bar to the actual value of y is this. Do you agree with me? The total deviation is the mean value is this much. This total. This is the deviation. This is big deviation. So see, you can see here, if you are not using regression, we are this much behind from the actual, from the reality. But of regression, we are able to bridge some gap. So this is something which we could bridge with the help of regression. So this variation, this deviation, this much we could explain with regression. But still, this is something which we could not explain with the help of regression. In the form of mathematical formulae to make it better. I said is y minus y bar is the deviation. Total deviation. Regression is being able to explain this part minus y bar is explained deviation This explained deviation, and this deviation, which is the residual part, y minus y hat, this deviation we are not able to explain with the help of regression. This is called as unexplained deviation. This is the aspect of regression. Please let me know if you have any question in this. You have understood these three terminologies. Now you will be able to understand the rest of the things very easily. For one data point, let's find out the value for all data points. So this is uh, total deviation for all data points. That will be equal to, if you do mathematical manipulation, some assumptions, you will arrive at this result. This would be equal to the sum of the squares of explained deviations plus what is called total of square, the sum of square term is sum of square or residual sum of square. Anyone? Something like box total sum of square. There will which will be explained. There will be some part which will not be explained. The it will be taken off by SSR, and unexplained part would be taken care of by SSC. SSR did by TSS total square or SST. I will start. So SST like this. For this good regression, This value should be high or this value should be low. Proportion should be high or this proportion should be low. Think it. I'm not. So regression is able to explain a few things. Regression to explain certain part, total deviation, okay, and some is not being able to explain. So I'm talking about this proportion, SR, regression sum of square. So of part. So explained deviation. This is the explained deviation. This explained. So uh, if you want to give it uh, this explained explained variation, proportion of explained variation. Of explained variation. It can't be more than one. How it can be more than? It can't be more than one. But yes, it is very high. It's to one. So most it's very close to one because you want regression in the maximum variance in y. So you want this to be possible. The portion should be as low as possible. Then should be as small as possible. You want residual. That is something which we have been discussing since half an hour. So then telling you the residual part, SSE, this should be as small as possible. Total of square, you want the proportion of square to be maximum. So this value should be as high as possible. How many understand? I tried to start from the scratch and to leave any stone unturned in regression. Explanation will be for you to find out at a single place. So if you're not able to understand this part, you please know I will try to read it and will try to it in a different way. I want it to be high. For a regression model, I want it to be high. It's called as R squared. else are required value. So as high as possible. It is sufficient of determination. Anybody? R square should be as high as possible for regression model. Please, any confusion in R square? This concept we to the next concept. Good. So let's under the concept. Uh, in which you face in regression. That issue is called as multicollinearity. The problem of multicollinearity. Let me tell you, regression start uh, in vast topic. Okay, so those things which are important for you to learn, which you will learn while practicing, while going for different varieties of data sets by learning on your own. This is the only way you can learn. So field. So there are topics which people find very difficult to understand, and the coefficient, this thing, problem multicollinearity. Is like those things which you would uh, you will find very difficult to get on any open source. But if you learn it here, if you consolidate your concept here, it will be easy for you to learn it from some other data sources. Okay. So understand what is multicollinearity. Any who can light on this concept, multicollinearity? Then you are right. Multicollinearity issue is about the independent variables. So when your independent variables are related to each together. And variables have high correlation among themselves. They face a problem of multicollinearity. This is with the independent variables. So suppose, thanks Niran, thanks Razika for your responses. Our create regression equation like this: y is equal to b plus x1 plus beta 2 x2 dot dot. Pick up x1, x2, say 3 x4 as well. Yes, you are right. Thank you so much uh, for coming in. So this problem occurs when you see the relation among these independent variables. The correlation between the independent variables, then some we see the uh, as mentioned by Niles. Okay, is the actually we can call it as. So a lot of things happen, but first of all, let's understand what this problem is, and how we can find out the solution of it. So mention again here, otherwise I will have to reiterate time and again. So first of all, let's forget about dependent variable here, since this issue is only with the independent variables. Okay. For independent variables, we have here x1, x2, x3, and x4. One thing, a model between these four variables. I'll pick up x1 and get a model between x1 and rest of the variables x and x2, x4. Regression model these variables. I'll find out the r squared value for this. Okay. I'll find out 1 minus r squared. I'll take the weight 1 minus 1 minus r squared. Can you tell me if regression model this one as a good model? You need to connect the dot here. If you this model to be a very good model, this equal to beta naught plus beta 1 x1 plus beta 2 x2. This model to be a very good model. You talk about this value, make this value to be high or you this value to be low. Let into the answering. Think about it. Try to connect the dots and answer. The original model y is equal to beta naught plus beta 1x plus beta 2x x2. If you will, to be good, but then you want it to be high or you want it to be low.
So we're saying low. Niranjan is saying low. Chiranjeev is saying low. Razika is saying high. Brenda is saying low. Okay. So most of you are saying low. Let's do it. Let's discuss it. The discussion is the best way. So, uh, understand, grasp the concept. Okay. So let's start with this R1 square. Sorry. Let's do this. For this model to be good, for one, the good, R square to be high or small, to be big or small. High. Let's make simple. This square you want to be high. What about this R1 square? You want R1 square to be high or you want R1 square to be low? Square to be low. We can just discussed the discussion. Told you that when we have relationship, we have the correlation among the variables, the problem in your model. Okay, so don't want this R1 square to be very high. We don't want. So what is R1 square? R1 square is the proportion of one explained by independent variables x2, x3, x4 in one. R1 square is proportion of variation in x1, proportion variation explained in x1 by x3 and x4. So you want this R1 square to be as small as possible. You want one square to be as small as possible. 1 minus R1 square would be as high as possible. Of it would be as 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 small as possible. So you want basically this value to be as small as possible for a good model. This value is called as variance inflation factor, VF. This is called as tolerance. It is 1 minus R1 square. It is called as tolerance. Once R1 square is called as tolerance, the rest of tolerance is called as variance inflation factor. Inflation factor is a statistical parameter is used to measure the density collinearity in a per variable. Okay, the which are acceptable to if we have the variance inflation factor more than 2, then we become a bit acceptable. Uh, so it should less. Okay. To find the values of variance inflation factor, mm, Oh, VIF. VIF is a keyword you can mention. Giving this forward slash, it will patient factor values. So you can the factor for age is 2.21686 and is 2.216. Anybody? So at this point, give you uh, to revisit, absorb these all concepts. I will be coming back to regression. Uh, what I will be doing, uh, station of machine learning, basically the supervised learning and unsupervised learning. I explaining you the clustering is a part of unsupervised learning, and then I'll be coming back to regression, and I'll explaining you some concepts with the help of the case study, because I've taken here a twilight asset, and then I will be taking you through logistic regression. Okay, so be done. You will have some time here because back-to-back concepts are coming here. Some people might get troubled here. Okay, so some good time to read the concepts, because now all these concepts will be you know considered sadly. So you should be very well versed with all the concepts, all the conceptual parts. Again, it depends on you. You will allow me to do. So be prepared before come to the next class with concepts, with all the basic things. Let's not get stuck only in the importing, only in the copying the data set. Okay. This file video which I'll be using uh, for training you the just a moment. This is good enough. This data set is good enough to take you through some remaining concepts uh, in. Okay. File and upload into SAS before you come to the next class. Let's use these 10 minutes we have here of discussion of what machine learning is, what is supervised, and what is unsupervised learning. and let's try to uh, at least understand the concept of cluster analysis. If not, seen this thing that machine learning is divided into two parts: supervised and unsupervised learning. I have a lot of interest techniques in my R sessions. DB scan clustering, association rules. I mean to say, specifically discuss um, market analysis, Bayes theorem. Okay, and in class, well, DB scan clustering is discussed in R sessions. You should know the concept before you go for those kind of classes. So, who can quickly come up with uh, there what is supervised and what is unsupervised learning? Okay, Niranjan, for your input. Uh, you talk about mathematically, you are very close. Supervised learning, when we know what outcome is and train the machine to learn it based on that, we're saying there is a target for supervised learning. Okay. So much for your response. It seems like you have some understanding of what machine learning is. Let me give you a different perspective. Let me explain you what supervised learning is in a different way that will actually help you to relate many things together. I'll talk in terms of human learning. So we learning because you also machine. We machine. We learn and then we walk. So our body is also a machine. So our body, the part of our body, our brain learns from the experiences, and that's what you want to do with the machines as well. That's why you call it machine learning. Super learning is very similar to do. So you at the behavior of all the humans, what we do activities. We do one thing. As a part of learning, we do one thing. We all bucketize. We bucketize everything, everything into different buckets. That is what we do all the time. When we meet anybody, that that person, we try to relate that person with all the people we trust, and and the we look at anybody, we try to bucket that person into some category. That person is short-heighted, that is a tall person, that one is fluent with the communication, that person is not fluent. Okay, is good, that person is bad. The moment we meet anybody, any person, any object, we always try to relate that object or that person with our past, whatever learnings we had in the past, whatever experiences we had in the past, we always try to match the new things with that. That's what we do every time. Always bucketize people, always bucketize. Uh, or I don't know whether I have written the right spelling. Bucketize, I believe. This bucketize, we always uh, guys. That is we do. All everything is done that way. Do you? So yes, based differences or bad, the salary or low or okay. So relation any question which I send across, you look at question. The more you look at the question, you try to bucketize that question. This question is difficult. This question is simple. This is do, and we do by referring the past. Whenever you do this kind of bucketization, this is called as super learning. So have some reference, conclusion based reference that is called as supervised learning. Anybody attention? Okay. Exam learning. Let's discuss about that. Uh, you are working in a company, uh, a company, okay, and a new customer has entered with you, and you want to be very about that customer. Predict this customer has propensity to commit, whether customer has a propensity to uh, okay. If you gauge those things, how will you gauge those things? How will you bucketize that customer into defaulter versus non-defaulter category? How will you do that? That what you will do, you would look at the data of the past. The past data you would have customer, basic details, age, salary, and you the information about their behavior, whether those people defected or not. Yes, know these kind of values. Past data, you the relationship, past experience. I may say you look at rules of the past. You see some relationship. Develop a relationship here that if age is between 20 and 26, if it is lying between this range and the reality is this, 6 liability to default can get from the past data. So how will you actually do it in supervised learning? I'll people already bucketized. Let me quickly try it for you. These are defaulters. People bucket to default category. These are defaulters. If we new customing to about the category, whether to put this customer into or to put it in category, what you do, you compare the characteristic of this customer, you compare qualities of this customer, qualities, those characteristics, maybe their demographic details, maybe their payment history, maybe their credit score, those may be the characteristic of this customer. These characteristics are compared with both the buckets and it put into that bucket which is uh, similar with the characteristic of this customer. This do is supervised learning. Am I making sense? Trying to learn dance from Prabhu Deva because he is doing dance like good. So they're about uh, learning. So take the difference of your past experiences and then you bucketize unsupervised learning. I have minutes of yours. End the session. Allow me 2 minutes. Anybody? Okay. So I'll give you the same example. Human. Uh, suppose you have some of you must be having kids. Some of you must have seen kids. Let's example of a kid of 8 years or maybe 1 year. Okay. This experience she has not seen in the past. So those kind of kids are given kind of games to play. They are to play like again they are given different shapes. Okay, the colors, and what if we'll put uh, different colors in front of them, what they will do, they will again bucketize. They separate out the buckets having same kind of colors. Okay, you different shapes. What they'll do, they will again do some kind of bucketization. Some shapes, and you ask if you would ask them to, you know, uh, join. They will kind of structure. That will be bucketization. So what I will do of here, the kids seen enough in the past. So not taking the reference of anything from the past. What the kid is doing, that is looking at the patterns. That kid is uh, looking patterns in the objects in front of him or her, and looking at the patterns, that kid again bucketizing the objects. Okay, supervised learning. Unsupervised learning, you just do one thing. You look at the pattern in the existing data. You from the past, you existing data, and then you bucketize. Ultimately, you bucketize only. Of unsupervised learning is cluster analysis. We create the mints of different people according to their preferences, according to their priorities, according to their demographics. Take the reference of the past in a well. So, in case of supervised learning, because we take the reference of the past, but cluster analysis will be the example of unsupervised learning. Okay. So, what cluster analysis? Let me quickly tell you. You look at different data points, recognize the pattern with data points. So the pattern is a very vague term. Distance between different data points, and then according to the distance, you club those points which may exceed kind of behavior. Okay, this is a part of unsupervised learning. I'll discuss more on cluster analysis in the next class. But it uh, earn request. It is my urge to you go through all the concepts before come the next class. Let's not waste everybody's time by asking some questions which I have answered many times. Okay, so for time, let's utilize this time the best way. I will uh, trans. I want to transfer maximum knowledge to you. Let, okay. Thank you. Let's meet next weekend. A wonderful week ahead. Okay. You guys next weekend. I'll pick up some questions here. Those questions. Those people who are done, they can leave. Thank you so much. And please take part in the survey, in the back survey. That is very important. Culinarity. Suppose I have 20 variables and 5 of which have more than 2, then we will remove 5 variables from the model. No. Should not remove everything from the model. You different ways to grapple with the problem of multicollinearity that I have yet to discuss. Okay, thing which to come, discuss it with the help of the data. Let me pick. And that you people are so curious about Shen. So simply gives this implication that to generate the interest in the subject. I'm so happy. This is something wonderful, everybody. The regression case study in the next session only on Saturday. Obviously, I will not be able to give it a lot of time. My yes, those will be discussed. Okay, so keep it till this only. See you everybody in class on Saturday. Have a very good week ahead. Go through the concepts. The next two classes are going to be very important classes.